My dear students, in this video I am going to solve some problems in inverse trigonometric functions in the exercise 4.5. In the first problem in the exercise, find the value if it exists. Find the value of the given functions if it exists. If not, give the reason for non-existence. That's the problem. Here in this case, sin inverse of cos pi. You know, cos pi is equal to minus 1. So, sin inverse of minus 1. Cos pi is minus 1. Sin inverse of minus 1 is minus pi by 2. It belongs to the interval minus pi by 2 to pi by 2. Therefore, the solution exists and the value is minus pi by 2. So the answer for this problem is minus pi by 2 if it exists in the interval minus pi by 2 to pi by 2. Second sum. Tan inverse of sine of minus pi by 2. Here, minus pi by 2 does not belong to the interval minus pi by 2 to pi by 2. Okay. So for that, this minus pi by 2, sine of minus pi by 2 can be expressed as tan inverse of sine of minus theta is minus sin theta, minus sin phi by 2. Because sine of minus theta is minus sin theta. Okay? So again, this is tan inverse of minus sine of phi by 2 can be expressed as 2 pi plus pi by 2. This is 2 pi plus pi by 2. 2 pi plus pi by 2 is 2 2s are 4, 4 plus 1, 5 pi by 2. So 5 pi by 2 can be expressed as 2 pi plus pi by 2. So 2 pi plus theta is again in the first quadrant. Therefore, first quadrant sign positive. Therefore, this is equal to tan inverse of minus sin tan inverse of 2 pi by 2 minus sin pi by 2. 2 pi plus first quadrant. Sin 90 is 1. So this is tan inverse of minus 1 because tan pi by 2 is minus 1. Okay. Again this is equal to tan inverse of minus 1 is minus pi by 4. It is belongs to the interval minus pi by 2 to pi by 2. So answer is minus pi by 4. Okay. This is the answer for the second one. So take these two sums and I will solve the third sum again. Okay. Next, third problem. Find the value of sin inverse of sin phi. Sin phi. Here, sin inverse of sin phi. This phi does not belong to the interval minus pi by 2 to pi by 2. Okay. For that, we have to consider this sin phi by sin phi equal to minus sin of minus phi. I can write this sin phi by sin of minus theta is minus sin theta, that is minus and minus plus sin phi. You will get. Okay. This is minus sin 2 pi minus phi. 360 minus theta, fourth quadrant sin negative. So minus sin phi. This is minus of sin minus phi is minus sin 2 pi minus phi. Okay. Again this is, I am introducing this minus within sin, that is sin of minus 2 pi minus phi. Sin of minus theta is minus sin theta. Sine of minus theta is minus sin theta. So I am introducing minus within the sign. It's again equal to sine of minus of 2 pi minus 5 is 5 minus 2 pi. So the sine phi is replaced by sine of 5 minus 2 pi. So sine inverse of sine pi, sine inverse of sine phi equal to sine inverse of sine 5 minus 2 pi. This 5 minus 2 pi is 5 minus 2 pi belongs to the interval minus pi by 2 to pi by 2. Therefore, the solution exists. Therefore, this is equal to sine inverse of sine becomes 5 minus 2 pi only. That's all about the answer for this. Sine inverse of sine phi is 5 minus 2 pi. Okay? Next problem in the exercise. Find the value of the given expression in terms of x with a reference triangle, with the help of a reference triangle. And I mean right angle triangle. For the first problem, sine of cos inverse of 1 minus x. You consider cos inverse of 1 minus x by theta. From this, 1 minus x equal to cos theta. Cos inverse of 1 minus x equal to theta implies 1 minus x equal to cos theta. So it can be expressed as a triangle. That is, this is theta, this is right angle triangle. So cos theta is, this can be expressed as 1 minus x by 1 equal to cos theta. Cos theta equal to adjacent by hypotenuse. Adjacent, this is 1 minus x, by hypotenuse is 1. This is cos theta. Cos theta is 1 minus x by 1, you consider 1 minus x by 1. Adjacent by hypotenuse is cos theta. From this I can get sin theta. Sin theta is opposite side. I want this opposite side. For that, this is equal to root of hypotenuse square minus of adjacent square. This side you want root of 1 square minus of 1 minus x 1 square. So sin theta, you simplify this, you get 1 minus of 1 minus 2x plus x square. So this is equal to 1 minus 1 minus into minus plus 2x minus into plus minus x square. Again you get root of 1 cancel. 1 minus 1 0. You get 2x minus x square only. So this side is root of 2x minus x square. This is your opposite side. So sin theta equal to opposite side by hypotenuse. Root of 2x minus x square by 1. That is root of 2x minus x square. So, sin inverse of, now the problem is sin inverse of cos of 1 minus x, cos inverse of 1 minus x is equal to this theta. You consider this cos inverse of 1 minus x by theta, therefore you will get this is sin only. Problem given sin of cos inverse of 1 minus x. This is theta we are considering. Therefore, this becomes sin theta. So this expression becomes sin theta. The entire expression cos inverse of 1 minus x is theta. Therefore, you will get sin theta. You know sin theta. What is sin theta? Root of 2x minus x square by 1. You need not write. By 1 again. Root of 2x minus x square only. So sin of cos inverse of 1 minus x is root of 2x minus x square. This is the answer for this problem by considering the triangle, rectangle triangle. Okay? Now consider the third problem. Tan inverse of, tan of sin inverse of x plus 1 by 2. You consider 2 as LCM, you will get, if you consider 2 as LCM, you will get 2x plus 1. By considering 2 as LCM, you will get 2x plus 1. So this problem becomes tan of sin inverse of, after taking LCM, 2x plus 1 by 2. This is the problem. You consider this sin inverse of 2x plus 1 by 2 as theta. Therefore, you get 2x plus 1 by 2 is sin theta. So, sin theta is opposite side by hypotenuse. Opposite side by hypotenuse. Sin theta is opposite side by hypotenuse. Opposite side theta 2x plus 1. Hypotenuse 2. So, this is your, from the reference triangle, right angle triangle, sin theta is opposite by hypotenuse 2x plus 1 by 2. We want tan theta, is it not? Sin inverse of 2x plus 1 equal to what is adjacent side? We want that adjacent side. From this side you want, for that you will get root of hypotenuse square 2 square minus 2x plus 1 whole square. This is equal to root of 4 minus of 4x square. 2x plus 1 square is 4x square plus 4x plus 1. Again by simplifying 4 minus 4x square minus of plus minus 4x minus into plus minus 1. So this is equal to 4 minus 1, 3 minus 4x square minus 4x. 3 minus 4x square minus 4x is the adjacent side. Okay. So, from this expression, this is, we want tan theta, because this is theta. What is tan theta? Tan theta is opposite by adjacent. Opposite is 2x plus 1. By adjacent side is root of 3 minus 4x square minus 5. This is adjacent side, this is opposite side. Tan theta is opposite by adjacent, that is 2x plus 1 by root of 3 minus 4x square minus 4x. This is tan theta. So the problem becomes, this is equal to tan, sin inverse of 2x plus 2 is theta. This is tan theta. So what is tan theta? This is the expression. Okay, the entire problem becomes tan of sin inverse of x plus 1 by 2 becomes tan theta. Tan theta is this is the answer for this problem. That's all about the problem. We want tan theta only. That is tan inverse of theta is this. Tan inverse of x plus 1 by 2 is 2x plus 1 by root of 3 minus 4x minus 4x square. That's all about the problem. Okay. Now, that problem, first subdivision, find the value of sin inverse of cos of sin inverse of root 3 by 2. This is sin inverse of cos of sin inverse of root 3 by 2. This is sin 60 is root 3 by 2. So, sin inverse of root 3 by 2 is 60. That is pi by 3. So, again, this is sin inverse of cos 60. Cos 60 is 1 by 2. Now sin inverse of 1 by 2 is again 30 pi by 6. So sin inverse of 1 by 2 is sin 30 1 by 2, 30 is pi by 6. Therefore answer for this problem is pi by 6. Okay, next problem, tan of sin inverse of 3 by 5 plus cot inverse of 3 by 2. For this problem, we have to convert sin inverse of 3 by 2 in terms of tan, because for this the sin inverse of 3 by 5, from this you get a triangle theta. Sin inverse is opposite by hypotenuse opposite by hypotenuse is sin theta, so this side is 4. From this sin inverse of 3 by 5 that becomes tan inverse of sin inverse of 3 by 5 equal to tan inverse of 3 by 4, opposite by adjacent. Similarly, cot inverse of 3 by 2. See, consider cot inverse of 3 by 2. For this, you consider the triangle, right angle triangle. This is some alpha. Cot is adjacent by opposite. Adjacent by opposite. Cot theta is adjacent by opposite. Cot theta is 3 by 2, adjacent by opposite. Cot inverse 3 by 2. From this, tan inverse of opposite by adjacent, that is 2 by 3. So these two expressions can be replaced by in terms of tan inverse. Therefore, the problem tan of sin inverse of 3 by 5 can be replaced by tan inverse of 3 by 4 plus cot inverse of 3 by 2 is replaced by tan inverse of 2 by 3. So the problem becomes in terms of tan inverse. So you can rewrite this as tan inverse of a plus b, tan inverse of x plus tan inverse of y is tan inverse of x plus y, 3 by 4 plus 2 by 3 by tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy, 3 by 4 into 2 by 3. This is again equal to tan inverse of tan inverse of this. Taking LCM as 12, you get 3 4s are 12, 3 3s are 9, 4 3s are 12, 4 2s are 8, 9 plus 8, 17 by 12 divided by 1 minus 6 by 12. So this is again equal to tan inverse of 17 by 12 by 1 minus 6 by 12 is 6 by 12. Right here. Okay. This step I can write here. This is equal to tan inverse of 17 by 12 by 6 by 12, because 1 minus 6 by 12 is 12 minus 6, 6 by 12, 12 cancel, you will get 17 by 6. So this is tan inverse of 17 by 6. So tan inverse is cancel each other, you will get 17 by 6 is the answer for the problem. That one. Okay. Next our problem. Fourth one, prove that sin inverse of 3 by 5 minus cos inverse of 12 by 13 equal to sin inverse of 16 by 65. From this you get sin inverse of 3 by 5. From this right angle triangle you will get an angle A, sin A, opposite by hypotenuse. Therefore adjacent side is 4. From this sin A is sin A opposite by hypotenuse 3 by 5. From this cos A adjacent by hypotenuse 4 by 5. Sin A is 3 by 5, cos A is 4 by 5. Similarly, from this cos inverse of 12 by 13. From this you consider angle B. Cos is adjacent by hypotenuse 12 by 13. Therefore, this is 5, 169, 144, 5. So from this cos theta equal to cos b, I mean. Cos b equal to 12 by 13 adjacent by hypotenuse. Sin b equal to opposite by hypotenuse 5 by 13. From these four expressions I am going to derive the result. How? We know one result in trigonometry. Sin a minus b equal to sin a cos b minus cos a sin b. So sin a 3 by 5 into cos b 12 by 13 minus cos a 4 by 5 into sin b 5 by 13 sin a cos b minus cos a sin b. Okay? So from this you will get 3 12s are 36 by 65 minus 4 5s are 20 by 65. From this you subtract 30 minus 20 is 16 by 65. That is sin of a minus b. Sin of a minus b is 16 by 65. So a minus b equal to, therefore a minus b equal to sin inverse of 16 by 65. Now what is a? Sin inverse 3 by 5. Minus what is b? Cos inverse 12 by 13. Cos inverse 12 by 13. Sin inverse of a. Cos sin inverse 3 by 5 minus cos inverse 12 by 13 equal to sin inverse of 16 by 65. The result is proved. That's all about the problem. And I stop my video here. I will continue the remaining problems in the next video. Thank you.